Hello and welcome to AI for Developers. I'm Chaitanya Talking Bot. Today's lesson is titled Embeddings and Vector Databases, giving AI a semantic memory. Imagine talking to a computer. When you say apple, you instantly think of the fruit. Perhaps its taste, color, or even the company. But for a computer, apple is just a sequence of letters. A, P, P, L, E. It doesn't inherently understand what it means, how it relates to banana or tree, or how it's different from Microsoft. Traditional computer systems are great at processing exact data or numbers, but understanding the nuanced meaning and relationships between words has always been a huge challenge. This blind spot prevents AI from truly understanding our language. To make computers understand words and their meanings, we need to convert them into something computers do understand: numbers. But not just any numbers. We need a special kind of numerical representation called an embedding. Think of it like a giant, invisible map where every word or phrase has a unique location. Words with similar meanings are located very close together on this map, while unrelated words are far apart. So, king might be near queen, and dog near puppy, but bicycle would be in a completely different neighborhood. From a developer's perspective, an embedding is simply an array of numbers, like backquote 0.123 minus 0.456, 0.789, backquote. This array is a numerical fingerprint or vector that captures the meaning of a word, phrase, or even an entire document. These numbers aren't random. They are generated by sophisticated AI models, often called embedding models. These models are trained on vast amounts of text to learn how words relate to each other. So the resulting numerical arrays accurately reflect the semantic meaning and context. The magic is, if two pieces of text have similar meanings, their embedding vectors will be numerically very close to each other. Once we have these meaning vectors, AI can do truly smart things. Instead of just matching keywords, AI can now understand concepts. Smarter search. Asterisk if you search for auto coverage, an AI using embeddings can find documents about car insurance even if the exact words aren't present. Better recommendations. Asterisk suggest movies or products that are conceptually similar to what you liked, not just those with shared tags. Question answering systems. Asterisk understand the intent of your question and pull the most relevant information from a knowledge base, even if the phrasing is different. Sentiment analysis. Asterisk determine if a customer review is positive or negative based on the overall meaning, not just specific keywords. Now, imagine you have millions, or even billions, of these numerical meaning vectors. Embeddings, representing all the text in your company's documents, emails, or product descriptions. If you want to quickly find all documents similar to a new query, a traditional database, like SQL, would struggle. It's designed for exact matches or structured queries, not for finding things that are conceptually close. We need a specialized tool, like a super efficient GPS for our word map, that can instantly locate all the nearby points. Similar embeddings. This specialized tool is called a vector database. It's a type of database specifically engineered to store and, crucially, rapidly search these high-dimensional numerical embeddings based on similarity, instead of looking up rows by ID or filtering by columns. A vector database uses advanced algorithms, like nearest neighbor search, to find the embeddings that are numerically closest to a given query embedding. It's like having an incredibly fast memory bank for all of AI's semantic understanding, allowing it to retrieve relevant information in milliseconds. even from massive datasets. Here's how developers put it all together to build powerful AI applications. Often using a technique called Retrieval Augmented Generation. RAG. 1. Embed your data. * Take all your company's internal documents, product manuals, knowledge base articles, etc., and use an embedding model, an AI service, to convert each piece of text into its numerical embedding. 2. Store in VectorDB. * Store these embeddings, along with a reference to the original text, in your vector database. 3. User query. * When a user asks a question, convert their question into an embedding using the same model. 4. Retrieve relevant context. * Send the user's query embedding to your vector database. It quickly finds the most similar embeddings, retrieving the original, relevant documents or text snippets. 5. Augment and generate. * Pass these retrieved, relevant texts to a large language model, like ChatGPT. The LLM then uses this specific context to generate a much more accurate, up-to-date, and relevant answer, avoiding hallucinations and leveraging your private data. This is a game changer for building practical AI solutions. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.